Jai Hind to all and very good morning. I am Professor Devendra Singh taking this module on machine design KME 602 and this is the second lecture of this module. In the first lecture we have discussed about the introduction of machine design in which we have covered the introduction of machine design, the various definitions related to machine design. We have discussed about the design cycle, design procedure, and we have discussed a little bit about the standards in the machine design and types of these standards. So, standards, we are aware that standards are set of norms we form to obtain the uniformity in the efficiency and effectiveness and reliability of any design product. Here we are moving to the second lecture. The in the second lecture, the outline of the advantages of the standardization. Then we will discuss about the introduction to steel and types of steel, and then we will discuss about the BIS designation system of the plain carbon steel. Then we will discuss the BIS designation of alloy steel, and here we move to the advantages of standardization. As we have already discussed the purpose and the importance of the standardization to make the design product uniform in efficiency, effectiveness and reliability. Some important advantages of standardizations are: first is the mass production. If we produce something in mass, then it will affect the cost of the product. अगर हम किसी चीज़ को मास प्रोडक्शन में उत्पादन करते हैं किसी चीज़ का, तो उससे उसकी कॉस्ट अफेक्ट होती है. कॉस्ट का मतलब केवल पैसा ही नहीं है. इफ़ cost involves a number of components to finalize cost of the product. It may include the labor cost, it may include the raw cost, it may include the transportation cost, etc., etc. And changeover cost. One is the changeover cost. In mass production, same arrangement we can use to produce the product. And in mass production is possible for the standard items. If someone asks me to give 10 products and if it is standard in size, shape and material, then I can plan to produce 20 and 10 I will provide to the consumer who asks me to produce it, और 10 मैं अपने स्टॉक में रखूँगा, इन्वेंट्री में रखूँगा और आगे जो इसका डिमांड आएगी I can provide that. In this way the mass production can be done, and if something we can produce in mass, it will make the product cheap and cost effective. This is the first significance or first advantage of the standardization. Lower manufacturing cost, as I have already discussed, lower manufacturing because mass production, so change over time इसमें कम हो गया, आपको एक ही अरेंजमेंट के साथ उस प्रोडक्शन हो गया, तो लोअर मैन्युफैक्चरिंग कॉस्ट. then improved quality. If we are using the standard materials, if we are using the standard items, standard elements in any system, then definitely it will work with high reliability and the product quality will be high by using the standard items. We have the data for the standard items from our past, and we can get the better and better quality for the product. So, in this way we will ensure the improved quality if we are using the standard elements. Improved service life. If quality is improved, reliability is high, and if reliability is high, it means the product whatever you designed with the standard items, that will give you the improved service life, better service life you will obtain from the standard elements or through standardization of the design components. Ease of maintenance and repair. अगर हम स्टैंडर्ड एलिमेंट्स अपने किसी सिस्टम में इस्तेमाल करते हैं, इट मेक्स अवर मेंटेनेंस इजी. एक सिंपल सा एग्जांपल है. इफ यू आर टेकिंग एन एग्जांपल ऑफ मारुति 800, and in Maruti 800 front axle bearing number is 6205. तो आप बेयरिंग अगर व्हील में आवाज़ आ रही है तो आप उसे इजीली मेंटेन कर सकते हैं. मेंटेन करने का simple, I can buy a bearing without opening the wheel. I will go to the shop, दुकान पे जाके बोलेंगे 6205, दिस इज स्टैंडर्ड एलिमेंट, वी विल गेट द bearing and we will bring it to the service station or to the place where we want to maintain our vehicle, then we can replace it. It will automatically, it will fit on the shaft. That is ease of maintenance and repair due to this standard element we have used in our vehicle. So, ease of maintenance in case of the standard elements we are using in our design system or design machine. Low running cost, if such kind of the maintenance is there, then maintenance cost is low. If we are using the standard element, so running cost definitely will be lesser, because running cost also include the maintenance cost. Then fast design and the production, we are having the standard elements, so we can make our design fast, only assembling is there, and we can produce the elements, standard elements in mass production, and in this way we can have the fast design and fast production if we are using the standard elements in our design product. Improved reliability of the system, I have already mentioned कि अगर हमारा standard element है, it will provide the improved quality of the product. Reason भी simple एक मिलता है कि अगर हम standard element इस्तेमाल कर रहे हैं, उसका previous life का performance हमें मालूम होगा, और we can continuously improve the quality, and if we are using the better quality elements in our design, so it will offer the better or improved reliability of this system. Then the next topic for this lecture is the steel. Steel is an alloy of the carbon and the iron. This is the ferrous alloy, carbon and iron. So, steel may be primarily classified in the two. Steel is classified in the two group. First is the plain carbon steel, and second category is the alloy steel. Right. What is plain carbon steel? What is alloy steel? Alloy steel is the steel in which some chemical elements we introduce, we add to get some improved mechanical properties for certain applications. So, those steels are known as alloy steel. So, it will be very clear when we complete this classification. So, plain carbon steel further classify in these four groups. First is the dead mild steel. First is dead mild steel, where the carbon percentage is less than 0.15%. It will come. Then second is the mild steel, third is the medium carbon steel, and fourth one is the high carbon steel. These plain carbon steels are classified on the basis of the carbon percentage, average carbon percentage content in this plain carbon steel. So, what is dead mild steel? The carbon content up to is 0.15%, that is plain carbon steel of and the category is dead mild steel. And if the carbon percentage is between 0.15 to 0.45% तक, अगर कार्बन का एवरेज परसेंटेज 0.15% से लेके 0.45% तक होगा, तो उसको बोलेंगे हम माइल्ड स्टील, जिसको हम बहुत अपने इंजीनियरिंग में पाते हैं माइल्ड स्टील का इस्तेमाल. Medium carbon steel, the carbon content varies from 0.45 to 0.80%. Then this is called the medium carbon steel. And high carbon steel, where the carbon content is from 0.80 to 1.5%. And if beyond 1.5%, then this steel, this iron and carbon mixture is called the cast iron. Right. So, steel is simple, the alloy of carbon and iron, carbon and iron. In these steels, in plain carbon steel, there is no significant additional element other than manganese. added. So, these are the plain carbon steel. Then the second category of alloy steel, where we have the carbon and ferrous alloy, carbon and iron alloy, manganese is there, and some other chemical elements we add to get the enhanced properties or enhanced mechanical properties or desired properties in the steel for our application. Those are called the alloy steel, and these alloy steel will be classified in three categories. ये तीन तरीके की होती है. पहली है low alloy steel. Low alloy steel are those alloy steels where the alloying element का sum परसेंटेज में अगर वो 5% से कम है तो वो बोला जाएगा लो alloy steel. Then medium alloy steel, if the total sum of the alloying element percentage content is between 5 to 10%, then this is medium alloy steel. And if the high alloy steel, if the alloying element, major alloying element, please note here we are saying the major alloying elements which are responsible for affecting the properties, mechanical properties of the steel. Those alloying elements, sum उनका sum हम यहाँ consider करते हैं. If sum is less than 5%, then low alloy steel. If it is in 5 to 10%, this is if it is 5 to 10%, then this is the medium alloy steel. If it is more than 10%, this is high alloy steel. It is there. Total alloying element up to 5%, low alloy steel, medium alloy steel, total alloying element 5 to 10%, and high alloy steel when alloying element are more than 10%. So, this is the steel. Now, we need to designate the steel. There are thousand types of thousand numbers of these steels available today for the application, for engineering application. So, we need to specify, we need to designate the steel, and these designations must be self explanatory. So, BIS, Bureau of Indian Standards, have suggested a method to designate the plain carbon steel and the alloy steel. So, there are two ways for plain carbon steel. First we discuss the plain carbon steel. So, there are two ways. दो तरीके से हम प्लेन कार्बन स्टील को डेजिग्नेट कर सकते हैं एज पर ब्यूरो ऑफ इंडियन स्टैंडर्ड. पहला तरीका है ऑन द बेसिस ऑफ मैकेनिकल प्रॉपर्टीज लाइक स्ट्रेंथ. सो स्ट्रेंथ हमारी हम नॉर्मली दो बात करते हैं. एक होता है यील्ड स्ट्रेंथ and second is the ultimate strength or tensile strength. Ultimate strength or tensile strength or tensile strength. So, on the basis of strength we can classify or we can designate, it is not classify, sorry. And second way, on the basis of chemical composition. Chemical composition means what are the components, chemical elements involved in this plain carbon steel. So, primarily कौन कौन से होते हैं? कार्बन होता है, आयरन होता है और एक मैंगनीज होता है primarily. So, first we will discuss about the on the basis of mechanical properties like strength. So, I take two examples to illustrate what is the meaning. There is Fe 350. Fe is what? This is iron. This is chemical symbol of iron, and 350 is what? This is strength. So, what does it signify? This is a plain carbon steel first of all. This is a plain carbon steel first of all, and it is having 350 strength. What kind of strength is this? So, this is the minimum tensile strength of plain carbon steel in Newton per mm square, 350 Newton per mm square. So, this designation, decoding of this designation is, this is a plain carbon steel having a minimum tensile strength of 350 Newton per mm square. This is plain carbon steel, straightforward. And second, suppose I write Fe, capital E, a third symbol, I have included this E. capital E. So, it indicates this is a plain carbon steel having 350 Newton per mm square strength. What strength is this? This is the yield strength, minimum yield strength. So, the designation, the meaning of this Fe is this is a plain carbon steel having a minimum yield strength of 350 Newton per mm square. So, this is as per BIS the plain carbon steel on the basis of mechanical properties. Now, come to the next on the basis of chemical composition. The chemical composition designation involves few steps, primarily 3 steps. First figure, then a chemical symbol of carbon capital C followed by a figure. So, वो क्या क्या है उसकी हम बात करते हैं अब. पहला फिगर, फर्स्ट फिगर indicates what 100 times the average percentage, 100 times the average percentage content of carbon. First figure you write or you will see to decode. This is always 100 times the average percentage of content. It is followed by a chemical symbol of carbon, that is capital C. Then it will be followed by the 10 times the average percentage content of manganese. This is, if this is a plain carbon steel, then this is the set standard method or standard steps to designate a plain carbon steel or to decode it. For example, it is required to designate a steel comprised of 0.4% carbon, 0.8% मैग्नीज. तो हमें एक ऐसे प्लेन कार्बन स्टील को डेजिग्नेट करना है जिसमें 0.4% एवरेज कार्बन है और 0.8% मैग्नीज है. तो सबसे पहले 100 टाइम्स ऑफ एवरेज परसेंटेज कंटेंट कितना हो गया? इट इज़ 40. 0.4 मल्टीप्लाइड बाई 100, इट इज़ 40. 10%, 10 टाइम्स ऑफ मैग्नीज, सो ये कितना हो गया? 0.8 मल्टीप्लाइड बाई 10 इज इक्वल्स टू 80. और बीच में क्या डालना है इसमें? सिंबल कार्बन का कैपिटल सी. सो इफ यू सी, it is very simple to designate 100 times. This is 40, I have calculated 10 times magnesium. This is, then designation is steel is 40 C8. This is simple designation, and if 40 C8 is given, then you can give the what is the average percentage content of carbon in this plain carbon steel. When capital C is there, it is अगर कहीं भी capital C इस तरीके का designation, it means इसका मतलब है ये प्लेन कार्बन स्टील. इट कैन नेवर बी द अलॉय स्टील. सो नाउ वी कम टू द अलॉय स्टील. फर्स्ट ऑफ ऑल, BI's designation of low and medium alloy steel. So, low and medium alloy steel where the total sum of the alloying elements must be from 5 to 10%. It should not be more than 10%. So, if composition are given, we should calculate first what are the total sum of the alloying element, then we should designate whether this is low or medium alloy steel. For both low and medium alloy steel, steps are same to designate according to BIS. First, in case of the BIS high alloy steel more than 10%, low and medium alloy steel, first of all a figure that will be indicating the 100 times. सबसे पहले एक नंबर होगा जो 100 times average percentage of carbon में होगा. Then it will be followed by a figure, it will be followed by a chemical symbol of a major alloying, first major alloying element जो सबसे ज़्यादा होगा, जिसकी एवरेज परसेंटेज कंटेंट सबसे ज़्यादा होगी, उसका सिंबल यहाँ पे डालना है. यानी कि क्रोमियम है तो Cr लिखेंगे, अगर ये फास्फोरस है तो P लिखेंगे, सल्फर है तो S लिखेंगे, और वनेडियम है तो V लिखेंगे. जो भी इसमें मैक्सिमम एलिमेंट होगा, फर्स्ट मैक्सिमम, दैट यू विल राइट जस्ट आफ्टर द 100 टाइम्स ऑफ एवरेज परसेंटेज कंटेंट ऑफ कार्बन, एंड देन फॉलोड बाय ए फिगर. इस फिगर के बाद इस केमिकल सिंबल के आगे एक हम फिगर लिखते हैं, और उस फिगर की क्या वैल्यू होती है? उस फिगर की वैल्यू होती है एवरेज परसेंटेज कंटेंट of the alloying element which you have already written multiplied by a factor, multiplying a factor, and it is rounded off to the nearest integer as per international norms, right. International norms means if it is 04.05, it is 4, or I should say 0.04.44. I will write it is 04, it is 04. If I write 04.46, it will be 04.5. If it is 0.04.5, I will take this as 5. If it is 0.44, I will take it 4. So, we never write in fraction in these designations. This I wanted to indicate here, right. So, this is there. Then we will write the second symbol, second allowing element symbol, which is having in this allowing element followed by its average percentage content. Then we will write next allowing element symbol and so on in the descending order of the average percentage content. And the multiplying factor you can get from any design data book. For example, in elements if chromium, cobalt, nickel, manganese, silicon, tungsten. So, the multiplying factor we are using for this multiplying factor only we will use in case of the low and high alloy steel, low and medium alloy steel, aluminum, beryllium, vanadium, lead, copper, niobium, titanium. This is for these all these elements. The multiplying factor is 10. For phosphorus, sulfur, and nitrogen, multiplying factor is 100. So, these multiplying factors we should refer from any standard design data book. So, now, this is an example. So, to designate the alloy steel having carbon 0.35 to 0.45% and chromium 0.90 to 1.20%. So, there is only chromium is there. So, the designation we need to find out what how should we designate, कैसे इसे designate करेंगे. तो average percentage content of carbon 0.35 to 0.45 दोनों का average लिया divided by 2 करके, and the average multiplied by 100. This is the first figure, it will be 40. The first figure will be 40. Then we calculate the average percent content of chromium, that is 0.9 and 1.220. So, this is divided by 2, it will come out something 1.05 multiplied by 4, it will be 4.2. So, it is 4.2. So, it should be rounded off to the nearest integer as per the international nomenclature or standard norms. So, I will take this as 4. So, what is the designation of the this alloy steel? So, the alloy steel, low alloy steel having the designation is 40 Cr4. Here in place of C, this is Cr chromium. So, if other than C star the first chemical symbol you find in any designation of BIS, then this is definitely a alloy steel, low, medium or high. It will be decided on the basis of the average percentage content of the all alloying element. So, here if alloying element, this is there is only information about chromium. So, it is only 2.10%. So, it is low alloy steel. Now, BIS designation of high alloy steel, this is very simple, there is no multiplying factor we need to use. This is the first we write X high alloy steel, we write X at the first letter of the designation. Then we write a figure indicating 100 times of the average percentage content of carbon. Then we write the chemical symbol of the first major alloying element followed by its average percentage content rounded off to the nearest integer. उसके आगे फिर second अलाइंग एलिमेंट सिंबल, फिर उस सिंबल के आगे आप लिखेंगे उस अलाइंग एलिमेंट की एवरेज परसेंटेज कंटेंट राउंडेड ऑफ टू द नियरेस्ट इंटीजर एंड सो ऑन in the descending order. You will write the complete designation you will get, and here we should note the average percentage content should be more than 1%. If it is less than 1%, then it should be written in underline. So, this is an example Uh, the composition, carbon having 0.22 to 0.28%, silicon is having 0.15 0.45%, and manganese is 0.35 to 0.55%, nickel is 2.5. This is the first highest. No, chromium is 12 to this is 12 to 19%, I think. So average percentage content. So highest is the chromium, highest is the chromium. So first is this carbon percentage 0.22 0.28. So we will get 0.20 average percentage content. Silicon is 0.15 0.45. So it is 0.3 average percentage content of manganese. We will get this is equal to 0.45, and then we will get nickel average percentage content is 3, then average percentage of chromium is 15. So highest percentage is chromium. So first chemical symbol we will use for the chromium. So thus the designation of the alloy steel, first is 100% of the carbon content is 20. Cr is chromium, is Cr is the chemical symbol of chromium, followed by its percentage content is 15. Then next is the nickel, nickel is 3. So this is our designation of high alloy steel. एंड इन केस ऑफ द हाई अलॉय स्टील ध्यान रखना है कि लो एंड मीडियम अलॉय स्टील में एक फैक्टर का इस्तेमाल करना है, हाई अलॉय स्टील में आपको कोई फैक्टर मल्टीप्लाई फैक्टर इस्तेमाल नहीं करना है. और मैग्नीज विल बी इंक्लूडेड, ये भी नोट कर लेना कि मैग्नीज को हम अलॉय स्टील में इस्तेमाल करेंगे इफ़ इट इज़ हैविंग एवरेज परसेंटेज कंटेंट मोर देन 1. अगर एवरेज परसेंटेज कंटेंट मोर देन 1 है तो आप मैग्नीज को इस्तेमाल करेंगे. विद दिस टुडेज लेक्चर I have completed, and the next we will start with the various concepts for the design against static load, material selection, etc., etc. So thank you very much.